In this video, we're going to show how to use factor label to solve word problems. Alright, our first problem says is that at a meeting, 28 people are each given 3 pens. If there are 8 pens in one package, priced at $1.88 per package, what is the total cost of giving away pens? Our process is going to be the same thing. First thing I want to do is identify what am I looking for, and what I'm looking for is cost, which is money. I know a lot about money in my head, but the first thing I'm going to do is check my problem and see what the problem tells me about money. And in this case, it tells me that it is $1.88 for one package. I have already found the unit I'm looking for, which is the money. Any other word I put into my data table, such as the package, I must have something to match it to get rid of it, because any other unit I put, I must get rid of because all I want is the money. So I'm going to read my problem and see what it tells me about packages. And what it tells me is that there are 8 pens in one package. Notice I put the package underneath each other. That way I can see immediately that I have 2 of those units, and I don't want packages anyway. I've added the unit pens. I don't want pens either, so I'm going to go back to my problem and see what it tells me about pens. What it tells me about pens is that each is given 3 pens. Each is a person. So 3 pens equal 1 person. So I have 2 pens. Those can cancel. I have added the unit person. I need to look at my problem and see what it tells me about people, and it tells me there are 28 people. So I have 2 packages, 2 pens, 2 people, 1 money. I have enough information to work this problem. That 28 people sitting all by itself is going to be my starting point because I don't want it and it is not an equality. So I'm going to start with the 28 people. I take all of my equalities, make them conversion factors because they're all equalities equal to 1. And if you notice on the diagonals, the people cancel, the pens cancel, the packages cancel, and I'm left with money. Multiply 28 times 3 times 1.88 divided by 8, or take 28 times 3 divided by 8 times 1.88. Either way, you'll get the same answer. This says that rowboats are $17.50 per half hour, and it wants to know what it'll cost to rent the boat for 5 hours. Cost, again, is money, so I'm looking for money. So in my problem, I'm going to go looking for money, and it tells me $17.50 per half an hour. Notice I wrote the half an hour as a decimal in this particular problem. I have money, I have hours, I need to get rid of hours. There's my 5 hours, 2 hours, 1 money. That's all it takes to work this problem. Start with the 5 hours, put equality in as a conversion factor. The hours cancel, leaves me with money, and I get $175 when I multiply and divide. I'm going to show you another way of working this same problem because we don't think alike, and as long as everything you put into your problem is valid information and true information, you can use it. It doesn't matter how many steps it takes to work the problem. Again, I want cost. Again, it tells me that it's $17.50 per half an hour. And notice here I actually put in the fraction. I need to know what goes with a half an hour when it's written like that, and the information is 1 hour is 2 half hours. I have half hours twice, I have hours once, I need that 5 hours in there. Again, I'm going to start with the 5 hours. 1 hour is 2 half hours, $17.50 is 1 half hours. The hours cancel, the half hours cancel, and again, I'll get exactly the same answer for my problem. This is one of my favorite problems, of course. A chemistry teacher provides each student with 8 test tubes. There are 28 students per class. How many test tubes are required for 3 classes? Now, the whole question is, how many test tubes? In the problem, I am going to go look for test tubes, and it says 8 test tubes each student. Then I have what I'm looking for, which is that 8 test tubes. I need to find out information about students. The information about students is one class is 28 students. Students will cancel. I need to find something for class. There are 3 classes, 2 students, 2 classes, 1 test tubes, enough information to work the problem. Start with the 3 classes, make all of your equalities into conversion factors, cancel classes, cancel students. You're left with test tubes, which is your answer. Do your multiplication and you get that answer. This is the same problem, but I want to show you a different way of working it. So far, we've always started with the item that is not an equality, which in this case is the 3 classes. The other way of working factor label, and whichever way you are most comfortable with, is the way you ought to work the problems, because this is sort of like working it backwards. I'm looking for test tubes, and I already know the test tubes. There are 8 test tubes, so I am going to start with that equality as a conversion factor at the beginning of my problem. So I have 8 test tubes is 1 student. Now I've got the test tubes, I need to get rid of the students, so my next conversion factor is going to be 28 students per class. Notice that the students still cancel. They're still on the diagonal. One still at the top, one still at the bottom. No big deal. Then put in 3 classes at the end. This way you have the unit you're looking for immediately, and anything else you just get rid of. The other way, you end up with the unit you're looking for. Here you start with the unit you're looking for. Either way is perfectly acceptable. In this problem, we have a totally different situation. Here we have kilometers per hour that we want to change to centimeters per second. Now, first thing I'm going to do is when I write my information, notice that I took the slash line and made it into a horizontal line, and that gives me a top and bottom unit to deal with. When I write the information given, I write it the same way. 50 kilometers over 1 hour. Kilometers is at the top, centimeters at the top. That's a good thing. They are both distance unit. If I start with the distance unit at the top, I want to end with the distance unit at the top. I have time units at the bottom. If I have a time unit at the bottom, I want to end up with the time unit at the bottom. So I have to find out the information to change kilometers into centimeters, which is a kilometer is 1,000 meters, and 100 centimeters is a meter. To check my 2's, I am going to take the 50 kilometers as one of the kilometers, and the 1 kilometer in the equality, that's my 2 kilometers. Then I have my 2 meters, and my centimeters cancel because I'm still not going to use that question mark centimeters per second to check to see if I have enough data. Then I'm going to do my bottom units. I have 1 hour written, and notice I actually put in the 1. A lot of people have more success if they put in that 1. And I know that 1 hour is 60 minutes. There's my 2 hours. 60 seconds is 1 minute. There's my 2 minutes. There's my 1 second. This is the information I need to work this problem. I'm going to start out with 50 kilometers per hour, and I'm going to change my top units first. I'm going to do kilometers to meters, then centimeters to meters. My kilometers cancel, my meters cancel, my centimeters are at the top where I want them. Then I'm going to change my time units. I have 1 hour at the bottom left. I'm going to cancel it with 1 hour over 60 minutes. Even though they're not next to each other, it doesn't matter where they are. If 1 unit is at the top, 1 unit is at the bottom, they will still cancel. That puts the 60 minutes at the bottom. Use my 1 minute is 60 seconds. The minutes will cancel. The seconds ends up on the bottom. So I have the units centimeters per second. Multiply 50 times 1,000 times 100 divided by 60 divided by 60. Every number below that division line is divided. So I'm going to divide by 60, then hit my equal. This is not to the correct number of sig figs, but don't worry about that right now. In this problem, we are converting cube units to cube units. Anytime you're dealing with square units or cube units, I find people have a big tendency to make really big mistakes doing it. So to solve a lot of problems, we're looking for decimeters cubed, and when I put down the information given, instead of writing it as cm to the exponent 3, I actually am going to write the centimeters 3 times, because that's what cube means. I don't know any relationship between centimeters cubed and decimeters cubed, but what I do know is that a 100 centimeters is a meter, and that 10 decimeters is a meter. This is all the information I need to work this problem. I'm going to start with the 5,000 centimeters cubed, and notice I put in the 1 meter over 100 centimeters 3 times, because that's actually the reality of it. You would have to multiply that 100 centimeters times 100 centimeters times 100 centimeters to get the correct number of centimeters. So by putting that in, all three of the centimeters cancel. Then to get rid of the 3 meters, I put in the 10 decimeters over 1 meter 3 times also. All the meters cancel. And here I take the 5,000, divide it by 100, divide it by 100, divide it by 100, multiply it by 10, multiply it by 10, multiply it by 10, and come out with 5 decimeters cubed. I have found that the people who do this and actually break up those cube units or any other power units, that if you actually write the unit that many times, you will not make nearly the number of math mistakes that people normally make. If you have any questions, write them down and bring them to class tomorrow. You will practice word problems during class tomorrow.